Now it's time to talk about what happens in the long run. So remember, in the long run, all inputs are variable. That means that when we're deriving our input demand curves, we'll derive demand curves for both labor and capital because we can choose our quantities of both labor and capital in the long run. Then we'll do the same thing we did before, plugging them into the total cost function to get total cost as a function of quantity, and then deriving from total cost our marginal cost and average total cost functions. All right, so first we have to set up our cost minimization problem to derive the labor and capital demand curves for this production function. So we want to minimize total cost, which is wages times labor plus rents times capital. Plus we have a constraint, which is our production function. So we've got 50L to the 1/2, K to the 1/2. And then we'll take our first order conditions with respect to labor and then capital. So we get wage minus lambda 1/2 50L to the negative 1/2 K to the 1/2. Oops, we'll set that equal to 0. And then find the first order condition for capital. Similar, 50L to the 1/2 K to the negative 1/2. Set that equal to 0. And then combine by dividing, we get wages over rents are equal to, a lot of this is canceling out, and we've got capital on the top and labor on the bottom. You can rewrite that so that we've got capital as a function of labor, because what we'll do now is combine that with our production function to get the labor and capital demand curves. So our production function is Q equals 50L to the 1/2 K to the 1/2. And remember, our goal is to solve for labor as a function of just quantity. So we'll plug in capital here. And let's move up. So we get Q equals 50L to the 1/2. And then we've got W over R L to the 1/2. So Q equals 50. We've got L to the 1/2 times L to the 1/2 is just L. And then we've got the W over R to the 1/2. So now we would just like to solve for L. So L equals Q over 50. And when I move this W over R to the 1/2 to the other side, I'm just going to get R over W to the 1/2. And that's my labor demand equation. So you can see that the more I want to produce, the more labor I have to hire, obviously. But the quantity of labor I choose also depends now on the price ratio of labor and capital, so that as labor becomes more expensive, if wages go up, I'm going to buy less labor. If rents go up, I would buy more labor as it becomes cheaper relative to capital. And then to get my demand function for capital, I'm going to take that and go back to this optimality condition. So capital is equal to W over R times labor, which I can now plug in. And again, remember here that this term we can write as W over R to the negative 1/2. This is W over R to the negative 1/2, and that will allow me to more easily combine with this term. Okay, so I've got K equals Q over 50 times W over R to the 1/2. All right, so we've got our labor and capital demand equations, and now we're going to write total cost as a function of quantity. So remember that total cost is WL plus RK, right? The sum of my labor costs and my capital costs. And so I'm just gonna plug in my demand functions now. And then simplify. And you'll notice here I've got W times I've got this W in the denominator, W to the 1/2 in the denominator. And so that's going to end up being just a RW to the 1/2. And same here, my R is going to kind of cancel out with this R in the denominator, so that what I end up with is Q over 50 RW to the 1/2 plus Q over 50 RW to the 1/2, which is, 2 times Q over 50 RW to the 1/2. So I've got Q over 25 RW to the 1/2. That's my total cost function, my long run total cost function. Okay, so drive the input demand curves, plug them into total cost and simplify, and now we've got total cost as a function of quantity.